Matt 1033, chapter 7, section 1. The whole chapter deals with rational exponents, radicals, and complex numbers. Okay? First thing you've got to understand to be able to work the problems in this chapter, you've got to at least know your perfect squares. And what I've done is I've listed the perfect squares up to 13 here, because these are the numbers you can only work with to reduce radicals that are square roots. You've also got to understand or know your perfect cubes. And these are the perfect cubes that, as far as I'm concerned, you need to know in order to solve perfect cube roots. So what happens is if we come to this first example problem here, okay, it tells us that we're looking for the square root of 36. Well, if I come over here, I can see that 36 is a perfect square. So what would happen here is it would be this base, which is 6. So the square root of 36 is 6. On letter B, the square root of 0 is 0, and it's perfectly all right to have a 0 inside a radicand, whether it's square root, cube root, or anything like that. Let me also say that as far as the test goes, I will not put any 4th root or 5th root or 6th roots, just square roots and cube roots. That's all you got to concentrate on. Letter C, I decided to do up here. So now it's square root of 4 over 49. Well, if that were able to reduce the fraction inside, that's what I'd want to do first, especially if it gives me a perfect square. Because it doesn't reduce, I can write the square root of 4 over the square root of 49, separate them. Then the square root of 4 is 2, the square root of 49 is 7, so my answer is 2/7. Done. Looking at letter D here in example 1, square root of 25 is 5. We have 2 decimal places, so we split that in half. So the square root of 0.25 would be 0.5. Okay, when we start to work with square roots, there's really a little imaginary 2 here, and we have variables. Now that 2 is not there. I wrote it in there myself. But for explanation's sake, because what happens is if we take this little 2 that's outside and divide into the exponent inside, we get x to the 6 over 2 power, which gives us x to the 3rd. And that's exactly what they did here. Going to letter F. There's letter F here. I'm going to go through the same process. You can see that I don't have the 2 here, but I put the little imaginary 2 here. I know the square root of 9 is 3. And I know if 2 divides into... And I know 2, outside 2 here, divides into 12, gives me 6. So the square root of 9x to the 12th is 3x to the 6th. Again, square root of 9 is 3. Little 2 divides into 12, gives me 6, so it's x to the 6th. We come over here, we start dealing with cube roots. Okay? And the cube root of 1 is 1. As a matter of fact, any root of 1 is 1. Remember, with odd roots, we can now have negatives inside. With square roots, we can't have a negative inside. So if you go back to here, it's okay to have the square root outside. Square root of 81 is 9, so this is negative 9. But in terms of here, when we have square root of negative 81, can't do it. No, at least not until the last section here, section 7. So this would be no solution, or not a real number, because this becomes an imaginary number or a complex number. So remember, it's okay to have a negative outside an even root, square root. You cannot have a negative inside an even root, square root. Going back here, I have a cube root of negative 64. So if I come here, all that, the 4th to the 3rd power is 64. Well, negative 4 to the 3rd power is negative 64. So letter B becomes negative 4. Letter C, I'm going to do the same thing that I did on the other problem. I've got the cube root of 8 over 125. 8 over 125 doesn't reduce evenly, so I write them separately. Cube root of 8 over cube root of 125. Cube root of 8 is 2, cube root of 125 is 5, so there's my answer, 2/5. We do the same thing with all radicals. See how there's this little 3 outside? If I take this 3 and divide it into the 6, I get x squared. So cube root of x to the 6th is x squared. Coming back to letter E, I'm going to do the same thing. I know the cube root of negative 27 is negative 3. I know this 3 divides into this 15 and gives me 5. Now we go to example 5, which is on page 420. In terms of this one, you've got to know how to work radicals, and for that matter, all the problems we're going into now, because there's keys that give it to you. So, for instance, we have a square root. We have a negative 3 raised to the second power. Well, I can't do the square root of a negative, so I'm going to raise the negative 3 to the second power, which gives me 9. Square root of 9 is 3. Done. In terms of this one, I got the square root of x squared, letting a little imaginary 2 outside, divides in here, so it gives me a 1. And I could put a 1 here if I wanted to. Make sure you understand that, anytime I have something in here, the radical outside, and I'm using a 4th root here as an explanation, but I could take this 4 and divide into that. It's going to give me 1. So my answer here is x to the x minus 2. Coming here, this is the same type of problem as letter A. I'm going to go ahead and raise this negative 5 to the 3rd power. I get cube root of negative 125, which gives me negative 5. Coming down here, square root of 25 is 5. Little 2 divides into the 2 on the inside, gives me x to the 1st. This problem here, I have to factor. So in terms of this x squared plus 2x plus 1 factors into x plus 1 to the 2nd power. If I take this 2 and divide into this 2, I get x plus 1 to the 1st power. And this is the last example in this section. This says f of x equals square root of x minus 4. G of x equals cube root of x plus 2. So the first problem is f of 8. So all we're going to do is take this 8 and put it in here, which is what they do. 8 minus 4 is 4, square root of 4 is 2. Done. We come here, we're looking at f of 6. So we're going to put the 6 in there. 6 minus 4 is 2, square root of 2. Don't give me a decimal. Leave it as a radical, a reduced radical. And we're going to learn in the next section how to simplify radicals. We go to letter C. It's g of negative 1, so we're going to stick a negative 1 in here. We get cube root of 1, which is 1. Last problem, we're going to do g of 1. So we put 1 in here. We get 1 plus 2, which is 3, cube root of 3. 3 is not a perfect cube, so don't get caught up in that. And that's what we're dealing with in terms of radicals. And one of the other things that it's going to do is it's going to show you the graphs of the square root of x and the cube root of x. They're very important in college algebra. Here's the graph of the square root of x. Notice you have a point 0, 0, 1, 1, 4, 2, 9, 3. Here's the graph of the cube root of x. And notice those middle 3 points, 0, 0, 1, 1, negative 1, negative 1. They're going to become very important later, especially when you go into college algebra, especially when we do transformations. I won't have transformations on this test for you. I'm not even going to have a question dealing with these two graphs. But you have to know these two graphs in college algebra.